The University of Maryland Clark School of Engineering is continuing its quest for the $250,000 AHS Sikorsky Prize for human-powered helicopter flight. Some say the requirements of the AHS Sikorsky Prize, unclaimed for 32 years, are impossible to meet. But don't tell that to the University of Maryland engineering students who have designed and built Gamera 2.
32 years this prize has been out there unclaimed. It's amazing, but it's still there.
That's because it's impossible.
It's not impossible. Nothing's impossible.
The goal is to fly 60 seconds and reach a height of 3 meters, or 9 feet 10 inches, within the boundary of a 10 by 10 meter box. The X-shaped quadrotor design of Gamera 2 is thought to be the best aerodynamic solution to win the prize. The 42-foot rotors can move a large volume of air and are low enough to take advantage of ground effect to create lift. Made of carbon fiber, styrofoam, balsa wood, and mylar, the Gamera 2 is so light, at about 71 pounds, that it can be powered by a 1/2 horsepower human engine, suspended on what looks like a recumbent bicycle with a hand crank.
There are both arm cranks and foot cranks. That's one of the things that really differentiates our design from a couple others. We get about like a 20% power boost from the arm cranks, and also they help level out the power that the pilot's applying to the rotors.
In the past, Gamera 2 has flown long enough, 65 seconds within a 10-meter box, and almost high enough, 9.4 feet, to win the Sikorsky Prize. But it has never met all 3 requirements of duration, height, and hover space in a single flight. If and when that flight occurs, it must be observed and verified by the National Aeronautics Association. In the week preceding this test flight, many changes have been made to this finely balanced aircraft. The carbon fiber superstructure was partially rebuilt. A new, lighter mylar was used on the rotors. The string pull transmission was redesigned with new bearings and rotors. And finally, a new computer controller system is being tested to keep the flight within the prescribed 10-meter box.
Three, two, one, fail.
Sure. Yeah.
Dip, drop, blade strike.
But there may have been too many changes to reconcile. Ultimately, it was drift and rotor design flaws that doomed this weekend's test flight.
We changed blade design, we changed transmission design.
Is that always true?
The blade design, there are some flaws in it. We have to go back and correct them. In the transmission design, we had some bearings which are not performing as we were expecting, so we have to go and change those. Okay. And so now the goal is to make all these changes and come back and carry out the test again.